in the last video about command and control, we talked about the basics of making a subsystem. And here I'd like to talk about a more big picture, like how it works. So generally, with command and control, you have a main process. It's either like usually auto or a TellyUp. And then you have a bunch of parallel subsystems running one process per subsystem. And by default, they'll run the reserve command. That's the whole point of the reserve command when nothing is being called. And then, so using auto and TellyUp, you'll call a command, and that'll get sent down to the controller, which will then override reserve. And then command A will be ran, like in this case, for subsystem 1, it's send down command A, and that would be run either until command A is finished, or another command is sent, which will then override command A if that's possible. Now, how you define when a command can be overrun and like when it's done running is let me just pull up an example. So you have these two things on here. You have a double and a boolean. So the double is wait time. So this is how many milliseconds you're willing to wait before checking for another command. And then the boolean is whether this command is currently finished or not. And if it is, it'd go back to reserve. Yeah, so that's the general structure. Oh, this is robot main, and I'm gonna explain some of the important files you'll find here that you should know about for command and control robots. So here's just the overall structure for running TellyUp and auto when the time is appropriate. So first of all, I'll talk about begin. So this VI is run once when your code is enabled, and generally you do things like connecting to I/O. We have joystick connections over here. We also connect to the IMU, and for pneumatics, we also do that in begin. You can also write to the network tables for displaying like autos or whatnot. We also have TellyUp right here. So this is code that runs during the TellyUp period. It runs in a 20 millisecond loop. What we do usually just pass some specific joystick values to our more subsystem specific TellyUps, which then runs the code and calls commands and whatnot. Alright, we also have autonomous.vi, which runs during the autonomous period. This just runs once, and this is like where you could say like make your bot drive forward, raise intake, and dump balls if you're a low scoring bot or whatnot. Yeah, we don't actually choose to run any of our auto code here. I'll explain. So we have two things. We have auto setup, which runs all these VIs down here. All these guys down here run after begin in parallel. Or not truly, because the Overrun doesn't have enough threads for that. But anyways, so this just reads in the paths on the Overrun and displays it to the network table. And then this could be in begin, but we like to split it out just for the sake of cleaner code. We also have this VI called Autorunner, which merely just takes the auto we push to a global and auto setup, and then calls the play path command, which we use to drive the path for our path planer. So yeah, that's just an alternate way of doing auto. Okay, there's also a VI similar to begin called finish, which, if you haven't guessed, it just runs once at the end after endgame's over. So what we do is we close our joysticks and then just stop all the code running. Now, not all of these are there by default. These four down here we added, like when you make added after we made the initial project. So we have some other VIs. Important one is subsystems.vi, which just calls all the controllers, which will then start the process for each subsystem. And if you don't have a controller in here wired up, then your dot subsystem won't run at all. We also have this VI called periodic tasks. This is just the generic VI that will have some loops running, which will then you can do as what the name says. We don't really use as much anymore, however. Another thing that we like to have is this folder called support code. This is just like a bunch of like libraries we use, like the IMU libraries here. We also have some vision stuff. Yeah.